Sorry for the delay, everyone. Good morning or good afternoon, depending on where you are. Welcome to the live digital session on the topic of why big data cloud migrations fail and ways to succeed. My name is Diana, and I am joined by none other than Unravel's Director of Solutions Engineering, Mr. Chris Santiago.
Hey, folks.
Before we start, just a few housekeeping bits. If you have any questions, as always, feel free to just drop them into the questions box and we'll answer them live. And if for some reason we don't get to them or we've missed it, we will respond. This webinar is available instantly on demand. So if you do have to drop off, feel free to come back anytime to this page and listen at your leisure. And then finally, please let us know what you think about the session by rating this webinar, and let us know if there are other topics or ideas that you'd like us to explore in future sessions. So with that, Chris, I'll let you begin.
All right. Okay, let me go ahead and share my screen here. So hey, folks, thanks for attending the screen. Diana, you can see my screen okay?
Yep.
All right.
Perfect.
So if you're here today, you're here for the topic of reasons why cloud migrations fail and ways to succeed. My name, Chris Santiago. I lead the global director. I am the global director of all solutions engineering over here at Unravel Data. I've been with the company for over 3 years. My LinkedIn information's there. My email's there. Feel free to reach out. I'm always happy to talk with folks about any of their cloud initiatives, modern data stack initiatives. What's the value that I can bring to you guys? I've been working through a number of folks, both US, EMEA, Asia, PAC, excuse me, and lots of common challenges, right? We're in an interesting situation where folks are starting to really start evaluating things from a cloud standpoint, and they have some existing legacy workloads that they're working on-prem. And so this is a common challenge that a lot of folks have. And so, throughout my years of working with Unravel, this is something that our tool absolutely does help with. But, why don't we start off by some high level numbers, right? And so this is, third party stats, but like, Unisys Corp reports that 37% of cloud migrations fail. If you're a Gartner fan and you get all your information from Gartner, 45% of organizations that perform lift and shift to cloud IaaS without optimization will be overpositioned by as much as 55% and will overspend by 70% during the first 18 quarters. All of these are contributing factors as to why folks who come in and they want to do their cloud migrations either are not getting their return on investment, maybe their customers their end users are not completely satisfied, and ultimately the project can be deemed a failure. And even worse, maybe you go back to the original state that you're in, and then it was just a lot of time, money, and resources wasted. And so why do they fail? So we're going to address that today. So I got a couple of topics that we're going to go through. First thing, common mistakes that I've seen customers go through that have resulted in failed migrations, right? And so I want to, have some common patterns that I've seen. Hopefully, if you start seeing these in your cloud migration projects, or maybe you're starting to formulate what that cloud migration journey may be, you should be aware of some of these common mistakes that I've seen folks that ultimately, without being addressed, ultimately lead to failure. Then we'll talk about just in general, hey, what are some ways that we can do to overcome these mistakes so that we can ultimately have a successful migration, not just from the start, not just from the whole journey and actually doing the implementation, but then also when you're at your future state, how am I making sure and ensuring that I'm getting the ROI that I expected? I'm getting the performance that I expected, and all the additional advanced features that you get from a cloud native solution. And then from there, last but not least, I want to at least give you guys an alternative of using a data-driven approach for achieving successful migrations, specifically with the tool of Unravel. And so first thing we'll start off is let's talk about some common mistakes that I've seen with failed migrations. And so first and foremost, it all starts at the beginning, right? You have an idea, you want to go into whatever that cloud vendors may be, whether it's Amazon, whether it's Google, whether it's AWS, whether it's IBM Cloud, you name it. You have to first start out by really understanding how the workloads that you're spinning into your environment, what are the interdependencies, all that good stuff, right? Um, and usually what customers will first do is they'll start leveraging core management services. So think of like Embari, think of like Cloudera Manager, and they'll start relying on these services to really kind of give you a good snapshot. And these services are really good because if you think about their use case of what what they're originally intending to do is they're supposed to give you very, very good platform centric metrics about what's going on in the environment, right? Whether your services are up, whether your node health is up, your CPU utilization, memory utilization, all really, really good metrics. What these tools tend to do though is their the audience is very centric to a platform engineer, somebody who needs to make sure that all the environments or all the services are up and running, so on and so forth. And so it's a great use case for those type of scenarios. But when you start thinking about, hey, I want to start moving some of these workloads to the cloud, it's really only telling you a partial story. It's giving you service level information, right? Not necessarily giving you as much details if you wanted to say, for example, understand, hey, how much do my this particular line of business, maybe I want to have them in their own environment. How do I decipher their workloads and their resource consumptions and their needs and their interdependencies? These management tools like an Embari or a Cloudera Manager, don't tell that full story, right? And when folks use this as a sole system of record for figuring out what that is, there's a lot of gaps that you're missing, which will ultimately affect your total cost of ownership, your effort to get there in terms of like, hey, how much services are how much just time and consulting resources to even get to that state. And finally, do I even have the right size environment, which we'll get here shortly. But yes, when it all starts in the beginning, and you need to make sure that you have as much information as possible about the current inventory that you have. The second piece where I've seen a lot of customers fail is the assessment isn't granular enough, right? We kind of talked about Embari and Cloudera Manager, and it's giving you very great information from like a services level, but maybe you want to start having different dimensions that you want to slice and dice by, right? Maybe my strategy is I want to bring things up like on a table level, like, right? So maybe I have a big master table. I want to go and upload that into the cloud. What are the services that are running in there? Is this part of a data pipeline? Which line of businesses are using this? All of this like connectivity, you're not going to get out of those those tools like an Embari or a Cloudera Manager. Now, the next thing that folks will do is they'll talk with the different line of businesses, the different tenants of the environment, and try to get this information. But even that's flawed because it's it's like a manual step. You're talking with folks, and you're ultimately basing what your level of effort will be based on what their best guesses are, what they tell you. I mean, if they tell you something and they forgot a big piece of component, that's obviously going to bite you once you start actually implementing this in the cloud, right? And so a lot of times folks just don't, they're only scratching the surface of all the information that they're collecting. And then once they actually get into the implementation phase, once they actually get into the future state, there's a lot of things that are missing, and ultimately, increased costs, so on and so forth. And that bites them, in the long run. So not being able to fully understand everything that you have in your inventory and all their interdependencies, definitely can lead you up for failure. Last but not least, just delays to implementation due to miscomplexities. This is I see this as a common pattern for a lot of the bigger folks that have maybe they've been using Hadoop for a number of years, and so and they have like, 10 or so different line of businesses using, the cluster, right? That obviously there's going to be some interdependencies, some relationships between, say, for example, I've got a data pipeline that may be using like an orchestration layer like Airflow and Oozie, and that's submitting up a combination of Spark jobs and Hive jobs, and they're hitting various tables, and there's staging tables, and there's production tables. And once and say, for example, I want to move that into my own like purpose-built job cluster, in the cloud, whether it's EMR, or maybe if it's like Google Data Proc, you miss one piece of that, it's going to bite you, right? We've seen time and time again horror stories of folks where, hey, maybe this is, I budgeted, a $3 million for this particular migration project, but as we're going through the steps, oh, I forgot about this dependency. Oh, I forgot that it's actually using this particular service. Now you're talking these overruns. Now this $3 million Hadoop project that we had initially budgeted for is now going to 7 million, 10 million. I mean, miscomplexities are huge. And again, it all comes back down to, do you have all the right data in front of you? So that way, A, you can understand exactly what you have in your inventory, all the dependencies, and then B, make informed decisions based on what you have at your arsenal. So again, high level, having an inadequate assessment of your current estate is crucial, just to make sure that you're starting off, on the right footing. Second thing is the next things that the next step that folks would do is they start kind of figuring out, hey, what's the total cost of ownership if I were to do this in my future state, whether it's a hybrid, whether it's a multi-cloud architecture. You need to kind of understand, like, hey, what are the instance types that I'm going to be using? What's the technology stack? Is it going to be Databricks? Is it going to be Snowflake? Is it going to be Redshift, or whatever it's going to be, right? You do have to, there's options on that side, and you have to make sure that you're properly sizing your environment, right? And so a lot of times folks, what they'll do, especially if they haven't done their homework, is they'll base it on like, hey, today I have these Dell nodes that are 64 gigs and have like 64 cores. I'm going to go the easy route, and I'm just going to go ahead and just pick the same kind of size VM that's in the cloud that mimics what I have today, right? The challenge with this is that a lot of times, unless if you have an environment that is just 100% just fully working 24/7, that doesn't really apply. There's going to be times, a common usage pattern that I see is you've got people that during business hours, that's where a lot of the resources are being used, and then non-business hours, the usage is not really there, right? On top of that, even during business hours, are you peak 100% utilization of the money that you had sunk from a hardware cost standpoint, right? And so when customers do their first pass at this, without the easiest way to do this is just base it on what I have today. And you definitely a route that you can go, but are you maximizing and making sure that you're paying for the correct resources, right? Because in the on-prem world, when I buy a server, it's a sunk cost, right? I can use 50% of it, 100% of it, whatever it is, but it's a cost that's already been applied, and now I just use it, right? Hopefully I'm using it to the max, but a lot of times we don't see that. In the cloud, it makes even more sense to make sure that you are sizing this accordingly, because you're paying as you go at this point, right? It's a different model, different costing structure. And so even more so, you want to be top of mind and making sure that you are taking advantage of accurately sizing your resources up in the beginning, because if you're not, and a lot of people find this out once they start sizing out and pricing out what these what the comparable sizes would be in the cloud, and they come to find out that, wow, it's actually even more expensive if I'm running this thing 24/7 versus if I were to keep this on-prem, right? And so a lot of folks will make that mistake of not doing their homework and just basing things on what they have today, and that's a recipe for failure. So also on the improperly sized future state topic, a lot of times people will just best guess it. Hey, this is where I'm at right now. I think I'm going to have 30% less resources based on, you know, math on the napkin, math, and say, hey, this is where I think I'm going to be at. And for obvious reasons, you could, if you're off, you're way off, or you could guess right, but it's like going to the casino, right? Kind of rolling the dice on what you think it is, not based on actual data that's actually been collected, is again recipe for failure. You could hit the jackpot, but most likely you will not, and you'll either be under resourced, over resourced, and then you got to deal with it then, and then at that point it's too late, right? So we've seen that, and if you are using kind of like your best guess, not based on scientific analysis on data points that you're actually collecting, that's a recipe for failure. And I've seen that play out many times for a lot of customers. Last but not least, sizing for multi-tenant architectures. So this kind of goes back to just really leveraging your cloud technologies. And when you are in the on-prem kind of mindset, and you have like the sunk cost of buying all these servers, you do want to kind of promote multi-tenant architectures, right? Because it's like, I've got these servers that are running 24/7. I've already purchased them, so I want to actually bring in as many workloads as possible, so that way I can get to that almost like 24/7 fully utilized state to really maximize, all the resources that I paid for, right? The challenge here is like in the cloud, doing that, multi-tenant architectures are great when you're trying to maximize like a sunk cost physical hardware infrastructure, but it also has its downsides, right? You're going to run into resource contention. You're going to have workloads that might be super compute heavy, and then they start backlogging all the other type of workloads that you're running, right? And so a lot of folks, with the advent of cloud, how easy it is to spin up these clusters. I can actually, hey, all my compute heavy resources, why don't we put them on a compute heavy resource cluster, right? And then maybe my batch jobs that are just always consistent, they can be on their environment, right? And so removing multi-tenant architectures to single tenant architectures is typically best practice depending on your workloads. But a lot of times what I see is folks will default to do this because, hey, it's the easiest thing. I'm not changing anything. This is what's working on-prem. But then when they come to realize and they try to mimic that same exact environment in the cloud, they see that, wow, this actually isn't a cost-effective measure here. And so, that is an architecture pattern that I've seen that, it's good for temporarily, like, hey, I just need to get into the cloud. Maybe my Cloudera license is expiring and I need to get into the cloud. Okay, that's great. But that's interim until you can actually start sectioning this off into purpose-built job clusters, if it makes sense, and really start leveraging, some of the cloud native features to really and effectively make sure that you're getting the best ROI for your cloud spend. Last but not least, I can keep on going on and on, guys, but I do want to kind of keep this concise for you guys. But where I see a lot of folks fail too is they're not really taking advantage of the cloud native features, right? So like, kind of one of the benefits, one of the great things about the cloud is it's so easy to scale up, scale down resources, right? It's not like when you're in an on-prem environment where I have to go through procurement. I have to go through Dell or whoever your hardware reseller is. Get this information, get the details, get it all plugged in, and get it all configured. And we're taking months on end here, right? In the cloud, it's literally just a click of a button or a configuration file or whatever it is, right? The challenge here is, if you don't know your usage patterns, you can't take advantage of things like auto scaling. And so, hey, like maybe I have I do need a cluster that runs 24/7. I don't want to run it down. And so, because I don't know like what my, my peaks and valleys are in terms of my resources, I'm just going to let this just run the whole time. The challenge with that is this isn't a sunk cost anymore. You don't want to have your resources just continuously running. You want to make sure that, hey, if I can actually scale down maybe my nodes in my environment during the less peak time hours, and then, scale up to the peak time hours, then now you're actually getting and paying for the resources that you're actually using. So if you're just going in and not doing the homework and just having your resources just continuously running, that's a recipe for failure, at least from a cost perspective. You're not going to get, your ROI goes less. And you have no idea that you're just wasting and spending resources and putting money for it, that you're essentially getting nothing out of it. Excuse me. The other advantage of the cloud is, now you have like this option of like, essentially just like putting in a configuration file of like the instance types of what you want. And what I mean by that is, if anybody who's familiar with like AWS and Azure, there could be, there's like a compute intensive like instances that are very, very powerful for like maybe like some data science workloads, or maybe you have some memory intensive workloads where it's like you're doing a lot of in-memory calculations, and speed is of most importance. You can have like just general purpose instances. For example, AWS has these Graviton instances, which are very, very tuned and for performance for big data type workloads, right? If you don't know these, if you don't know the differences between these two, you may not even be picking the right instances, right? And so without that, you could be a very compute heavy workload, but then you're using general purpose and you're not getting the most out of it. And now your bottleneck is the compute. And that's taking long, and the longer it runs, the more that you're paying for it, yada, yada, yada. And so, you're not taking full advantage of it. You need to have additional insights to know, hey, this is a good instance type for my particular workload. And you got to do the homework in order to understand that. Last but not least, you've got this concept where the cloud vendors, they have like, whatever data center that you pick, they have, they're going to either have what you're asking for or they're not. And so what these cloud vendors will do is they'll have like a plethora of different types of like instance types, right? Now the challenge here is when you come in and let's just say, hey, I want to have like an M4X large and in AWS, and I ask for that. And in my data center that I'm asking it for, it's just not available because everybody else is using it. I gotta wait. I gotta sit there and wait, And so to take advantage of some of the unused inventory that the cloud vendors do is like they say, hey, I have something that's similar and in size. May not be exactly it, but it'll definitely address your requirements. And so here you go. Think of it as like, we'll let you borrow it for a little bit, right? The advantage here is that the prices are very significantly discounted, right? And so because they know that it's not exactly what you asked for, you can really take advantage of that. Same thing with reserved instances. So like this would be more from a contractual standpoint of like, yes, yeah, I know I'm going to be, and say, for example, from a Databricks perspective, I know that I'm going to be probably spending 1 million DBUs a year. It's obviously just like anything else, you're buying it in advance. You're going to get, a discount for that, right? The challenge here for folks is a lot of times they don't know, years out of like what their forecasted spend are. And then in the instances of like spot instances, those spot instances, while it's great that, the cloud vendors have these options of giving you discounted pricing, the disadvantage of spot instances is that they can easily take it away from you because it's a borrowed instance, right? So if I'm asking for a particular instance, they give me an instance as a spot instance at a discounted price. If a customer that actually requested that price or that node, and paying on demand, retail prices, that node is going to be taken away from you. So there, you do run risk of, the vendors taking this away. And so that's the trade-off. Like they'll give you a discount because it's not being used because it's in inventory. But if somebody asks for it, they'll take it back. And so that's the reason why it's discounted. And so certain things, certain instances or certain scenarios, really warrant, taking advantage of spot instances. You don't want to have like your mission critical jobs all under spot instances, because that mission critical job could have, quite easily get all the, your instance types yanked from you, at the time that you really need it. So it's just understanding like your usage patterns, and without having a full data set of that, you could be making the wrong decisions, and it could be adversely affecting you. Even worse, you could just paying the list prices, on demand prices, just for everything, because you didn't do your homework, because you don't know what your reserved instances are, you don't know what spot instances are, so on and so forth. So, all of this stuff, in combination, or maybe even one thing, more than others, these are some of the things that we notice that customers, if left unchecked, will definitely affect your cloud migrations to the point of worst case scenario failure. But at the very least, not getting the return on investment, not getting the customer satisfaction that you were expecting in this new cloud environment. So now that we've been kind of talking negatively, let's talk about positive things. Okay. Let's talk about things that I've seen in my experience working with customers, large and small, on how we can actually overcome these and have a successful migration. So just in general, just from an assessment standpoint, you do need to look at things above and beyond some of the out-of-the-box tools that you have, like a Cloud Area Manager and Arbari. Like I said before, these are very platform-centric services where I see a lot of SIs and consulting companies, and even just companies that are just doing themselves, rely on this, and it's only telling you a partial picture. And like we were saying before, you need to have as much data points to really understand the workloads, to really kind of figure out what your total cost of ownership would be in the future state, as well as the level of effort. Like, is this going to be a 10-phase approach? Is this going to be a 3-phase approach? How complex is this going to be? How many resources do I need to assign to this? What are the best technology stacks once we're actually in the cloud? To really understand that you really can't answer all those questions definitively unless if you have all the information collected ahead of you when you're doing your assessment phase. When you are sizing out what this may be in Databricks, whether this may be in Amazon EMR or Google Dataproc, you really need to go even beyond what Cloud Area Manager is telling you, and you have to kind of understand what the actual usage of resources are. What I mean by that is, I can be a Spark developer and ask for, all of my jobs, I'm going to ask for like a gigabyte or maybe even 500 gigabytes for my job. Are you doing the research to understand that, like, do you really need 500 gigabits per job? Maybe you could run that same job for just using 5 gigabytes, and you were just over allocating your job for, for each runtime, right? You really need to kind of get a deeper analysis of the workloads that you're looking at, and making sure that you're sizing this based on actual usage. If the name of the game is making sure that you're properly allocating your resources, and you're making sure that you're not over allocating, aka overspending on resources that you're not using. So having an even deeper analysis on how the applications that are coming in, and actually basing my sizing based on actual usage, is key. It's a hard ask, but it is something that we do taking care of with Unravel, which I'll show you here shortly. And last but not least, I mean, this goes without saying, guys, you got to take advantage of the cloud native features. From an on-prem perspective, you've got some pros and cons from that standpoint. In the cloud, it opens up a bunch of features that, like, if you're not aware of this stuff and you're not taking advantage of it, you're not going to get the full ROI of what you're expecting in terms of performance, in terms of cost for your for the workloads that you're moving up, right? So auto scaling, super powerful option, right? How do you know when to auto scale? How do you know what your baseline, node should be, right? We talked about like the spot instances and the reserved instances, right? maybe a strategy could be, hey, I want to have an auto scaling persistent cluster, but maybe based on what I'm seeing, my minimum may be like 40 nodes. Okay, that can be my on-demand pricing. Like, don't touch my pricing. I'll pay the top dollar for that. But maybe based on the particular workloads that are coming in, maybe I can auto scale that. And that could be spot instances. That could be reserved instances. So there's ways to, really kind of, I don't want to say game the system, but like if you have a really good understanding on how your workloads are being used, how they're scaling up and down, now you can start kind of slicing and dicing and adding these additional parameters of, really making sure I've got a combination of on-demand, reserved instances, spot instances, and now I'm really saving money. Instance types, again, we kind of talked about this before, but making sure that you have, understanding the type of workloads. Is it memory intensive? Is it compute intensive? Make sure that you're picking the right instances. And the only way you can do that is if you have a good baseline knowledge of, the workloads that you're spinning up. And then last but not least, single tenant job cluster architectures. Your results may vary, but a lot of times, especially for folks that may be doing a lot of batch jobs and they're only running jobs at, say, for example, 10 p.m. Maybe it's like you're taking in all the data from your store's inventory and maybe putting it into like a data warehouse, and it only runs at 10 p.m. There's no sense for that to have a cluster that's always running and being persistent. It makes more sense to have this as like what folks will call a job cluster, where I'm going to go and I'm going to spin up a cluster, have the number of resources that it needs to run. And maybe it's like a 1 hour job, maybe it's a 4 hour job. But once it's done, spin the cluster down. So now you're only talking about paying for an hour's worth of resources, 4 hours worth of resources, as opposed to paying for something that's always on, right? This other concept of single tenant architectures is, moving away from this whole multi-tenant architecture where it's like, people are competing for resources, especially during peak time, right? Now I can actually say, hey, maybe I have some bursty workloads from my data science folks, right? Put them on their own cluster, let them burst, maybe do some auto scaling from there. But maybe they're compute intensive, and maybe I can have my batch workloads using just general compute because that works for my particular workloads. Now you can start mixing and matching these things. And so you can have job purpose-built clusters for the particular workloads, and also using the right instance types. So that way you really are maximizing for performance and cost across your workloads. So again, your results may vary. Sometimes it makes sense to have a multi-tenant cluster. Maybe it makes sense to have a cluster that's always up and running, because maybe it's like an interactive type of environment where, I'm doing a bunch of ad hoc queries and I don't want to wait for, clusters to spin up. But like, these are the things that you need to take advantage to really reap the benefits of the future state, the cloud technologies that you are planning to use. And with this is how you can really kind of guarantee that you will have a successful cloud migration, as you move forward. Now, we've been kind of talking about things, very conceptually right now. But what if there was a better way? What if there was a way that really kind of pushes this data-driven approach for successful migrations? In fact, here's a quote from Gartner for folks that live and die by Gartner quotes. But data-driven approach for planning and migrating is critical to success. And that goes without saying for anything. Like, the more data points you have, the more you can actually make informed business decisions on what you can do. Now, on what Unravel can do, we can actually help you in every stage of the journey, right? Whether you're making a case for the cloud. And so this would be like the assessment phase. Like, what is my total cost of ownership if I were to do Azure, if I were to do AWS, Google? What is that? What are some of the things I can get, benefit from there? Once I've made the decision that yes, cloud is for me, how can I make sure that I can accelerate this migration, right? Because, hey, these are production workloads that are running today. How can I make sure that this becomes seamless as possible so that way I can get to the cloud faster, and make sure that, like, as I'm working through the migration, I'm, checking off all the, options of, making sure that we are performant and saving costs, all that good stuff. And then once you actually are done with the migration itself, how am I making sure that my customers are still satisfied, my end users are still getting the same results that they were expecting, but now we're actually driving costs even further because we're using a lot of the cost-effective measures in the cloud. Those are all things that you need to do. And what I'm about to show you here is how you can use a tool like Unravel to help you get there from a data-driven approach. So I'm going to switch over here into demo mode now. And so what you guys are seeing on my screen here is Unravel in action. And so before we get into the actual screens itself, what we'll do from an installation perspective is we'll install into your environment. And once we're installed, very, very simple install, we come in and we start indexing things. We talked about Cloudera Manager. We talked about Embari. That's a data source for us. But in addition to that, we're also looking at things such as like the applications, like the Spark jobs, the Hive jobs. We're looking at the infrastructure itself, like how much utilization from a CPU standpoint, from a memory standpoint, are we actually using? We're even drilling in and actually making connections to the Spark jobs, the Hive jobs, whatever jobs that you're running into your cluster today. What are some of the data sources that they're connecting to? What are the tables that we're using? It's a real holistic picture that's actually combining things on the service level, on the platform level, on the application level, and really tying things together. So that way you can answer these questions of, okay, maybe I want to move away from a multi-tenant architecture to a single tenant architecture. What does that look like? And this is what we want to show here. And so we've got a couple of options here. Actually, let me move out here of full screen here. 1 second here. So I need to get to my tabs. So sorry if you like the full screen, but this is going to work for me. So what we first start off, just like with any other cloud migration, is assessment. Like you need to get an inventory of what's going on with your environment today. We talked about before, like this is normally a manual process because there is no tool out in the market today that's going to get down into the nitty gritty and really show you all the intricacies, all the dependencies, all the relationships of everything that's happening within your cluster, whether it's services, whether it's nodes, whether it's applications, yada, yada, yada. You get all that information here without even asking anybody, right? We're indexing this information for you. And, here's an example of a dashboard that we show. So if you're looking to look at things from like from a services standpoint, like what are my services? What's my security? What's the OS that I'm running in? What are some of the services that I'm running? What are some of like the hosts? So this would be like the servers that are in my environment. What's their host role? How much cores are they using? Memory, disk, all this good stuff. I mean, this all gets factored in obviously when we start thinking about future state, right? Here in the middle here's where we can start getting a little more granular and we start showing that relationship with the type of jobs that are actually being submitted. Is this a heavy, in this particular case, it looks like it's, we've got a decent amount of Spark jobs, right? So this could be data science. People maybe could be running their machine learning algorithms, maybe some AI, and then some of this stuff, maybe like MR. So that's MapReduce. So this would be like batch jobs, maybe, ingestion jobs, ETL jobs, whatever it may be, right? But you don't know what you don't know. And we start giving you that visibility, right? This is the type of, all the jobs that come in, this is how it breaks down. We can look at things from a user perspective. And so maybe a lot of folks, really use service accounts, very heavily. And, a lot of times this is an eye opener for folks of like, hey, out of a resource consumption perspective, did you know that in this particular case, it's the HDFS user is using up 77% of the resources? A lot of times people don't know that, or by queue. So if a lot of folks use by queue, you can look at it from that perspective. Again, it's giving you all this insight so you can start really kind of formulating what that future state may look like. On the right-hand side here, now we start looking at things from a overall just resources perspective, right? CPU consumption, memory consumption, over time. The red line here is my capacity. The purple line here is the actual usage. A lot of times this is an eye-opener for folks because they're like, hey, I spent a lot of money on my, my hardware infrastructure, but I didn't realize I'm only getting average 32% of utilization from a memory perspective, 23% utilization from a CPU perspective, And so this gives you kind of like a good kind of time series perspective on how resources are being used. This is also going to be useful for identifying, hey, this is a bursty type of environment, maybe like Monday through Friday is where all my resources are being used, Saturday and Sunday, not used at all. Okay, that can factor in when you start thinking about what that forecasting may be for your future state. Down here below, CPU, this is a heat map. So this is going to look at things from CPU perspective, memory perspective. Again, very similar to what you're seeing here, but this is useful for just identifying like, is my Monday in this particular case, looks like Monday at 10 a.m. heavily used. Okay, that's useful because again, this is going to really help tailor you, give you all the data so that you can make those informed data-driven decisions on what that future state may be. So from an assessment phase, this is very, very helpful. And from an implementation like effort generator phase, like, hey, is this going to be a phase 1, phase 10? How am I going to break this out? Again, this becomes very helpful because now I can understand like, hey, maybe I want to do my Spark workloads first because they're taking up, over 50% of my resourcing. These are some of the questions that we want to answer. So that way you make an informed implementation plan, effort estimator plan, however you may want to call it. We want to make sure that we get as granular as possible so you can make an implementation plan that is going to resonate and actually make sense. And you have the data to back it up to ultimately de-risk your migration strategy. Now, let's talk about some of the other things that we have here. We have this cloud mapping per host. And so cloud mapping per host is, we've got a couple of scenarios where now we're talking about forecasting, right? In terms of like what this may look like in my future state, in my cloud, whatever I select. Now, the beauty of Unravel is, we are cloud agnostic, right? We do want to support whatever you decide, right? So for folks that maybe they haven't decided on EMR, Azure, Google, Databricks, we also support too here as well. And they want to just have the ability to kind of understand, hey, what workloads make best, based on the decisions that I make. We give you that option for you. So in this particular, this is the options section here. And so I would pick, the cloud service, the region, the type of VMs. And so a lot of times, a lot of folks will maybe take out the smaller, the what do you call it? The older, VM types, and maybe you want to focus in on some of the newer ones. You have that option. Custom cost here. As you can see here, we're actually pulling the retail, basically the highest costs for the VM types. A lot of customers already have agreements with the vendors about like what that custom, what the actual cost may be. And so you do have the ability to put that in here so that way you can have a more accurate model. But once you actually have all this stuff selected, you select run, and then you get this output. And so this in this particular example, in a lift and shift model, we're going to show it to you in two different ways. We're going to show you in a way of like, hey, if we want to base our analysis based on physical hardware, how much actually I'm going to try to mimic what I have today in my physical environment today with my how much memory, how much resources that I'm using. Here you go. This is what's going to cost in this particular example, going to HDN site. If you were to mimic what you have in your environment today, doing minimal analysis, basically just saying like, hey, I just want to mimic what I have hardware today. Here's your cost, $472. But with the insights that we have with Unravel, we can actually base this on actual usage. And based on that, we can actually get down into the node level and say, hey, you know what? $472, you're only using 20%, 30%. I forgot what it said on the cluster discovery. But if we were to actually size this based on how you're actually using the resources in your current environment, you could actually skim a lot of that stuff down. And so now we were able to take that $473 price down to $168 per hour. If you do the math, that's millions of dollars per year that you're saving just by running an analysis of Unravel into your environment. So significant cost savings here, guys, and to really understand things from a lift and shift perspective. Now, last but not least, we've got a workflow fit model here. And so this would be for folks that maybe I want to modernize out the gate. Maybe, maybe I want to just like have, I want to go straight into single tenant architecture. My Spark developers are always complaining that there's never enough resources for me. So I don't want to deal with them anymore. Let's bring these Spark developers into their own particular environment. But I don't even know where to start because Cloudera Manager and Bari, like they're not giving me these details or the ability to kind of slice and dice only their workloads and figure out like what an environment would be if I were to go into a single tenant architecture. And so this report gives you that ability. So I can come in here, select multitude of things, whether it's a job type, user, queue, tag. And so tags is also a powerful feature where we have the ability to select, a specific custom tag, as you will. And so if we want to do it by a particular user, a particular job type, a particular database, we can do that as well. But I'll keep it simple. I'm going to say, hey, Spark workloads, I want to get my data sciences into the cloud as fast as possible. And so I'm going to select that. I've got some other dimensions here that I can look at. So I can look at it from how much Spark resources are they taking from a memory perspective, from a vCore perspective. And so now I can start looking at this and being like, based on what I'm seeing here, it looks like, if I were to move these guys, I do see some burstiness here. It looks like Tuesday, Wednesday, Thursday, Friday, it's pretty heavy and go down, and it goes down, right? And so I start getting that type of information. Once I actually select a slice up top here, here's where things get interesting, guys. Now I can come in and actually say, okay, HD Insight, I'm going to run this. If I were to put them into their own Spark clusters in HD Insight and Azure HD Insight, in this particular example, we could do this also in Databricks as well. What is this going to cost me? And what are the recommendations? So 100%, hey, I want to make sure that, you're not going to affect any of my performance, but I do want this accurately sized based on how they're actually using up resources. Here's the cost associated with it, $212. Here's the recommendations of the instance types. Or we can go down to like 80%, where it's, hey, maybe I need to further reduce costs. And if 20% of my jobs actually get affected from a performance standpoint and they run a little bit longer, I'm totally fine with that. Here's a recommendation from that. Another thing that we can do too, which is very, very powerful, is we can provide some options for auto scaling. And so again, based on actual usage, based on how like the folks are actually using the cluster itself, we can actually provide, if you were to use auto scaling, you can even further reduce costs, 18.55% cost down to, from $212 down to $172. Obviously that's very great. Another option that we're working and building in is actually even providing options of saying, hey, what's the minimum cost or the minimum number of nodes? And that can be your on-demand nodes that never changes. You're never going to go under that. And then anything above that, that can actually be good candidates for those reserved with those spot instances, which are a lot cheaper, right? So, some of those spot instances can be like 75% less than, what you're paying for. Even further reduction in costs, right? You don't know what you don't know. You need a tool like Unravel to really kind of analyze your workloads, understand the peaks and valleys, and ultimately give you the option for you to slice and dice it the way that you think is best, and then ultimately get a great understanding of the total cost of ownership, the level of effort. And we haven't even scratched the surface, but we do also have management capabilities, and we can help, once you're actually in that future state, further optimize and reduce costs from that standpoint. All right. So going back into my slides here, I know I'm trying to manage my time here correctly. We've gone through a lot of things here, guys. We first started off by talking about some of the common mistakes from failed migrations, whether it's not assessing your environment properly, not sizing your future state accordingly, not taking advantage of some of the cloud native features that will get you, to a good state in your architecture. Then we talked about just high level things that we can do to overcome those mistakes so that you can become a successful migration. And last but not least, using a data-driven approach, using tools like Unravel So that way we can actually automate this and, and index and understand all the different types of workloads. So that way you as an end user can make the best decisions based on, a data-driven approach to ensure success in your migrations. Last but not least, if you want to try us today for free, we do have a SaaS free trial option here. The only caveat that I would say right now, guys, is this is more in tune to optimization of our management capabilities. So think of things such as like, I want to optimize my jobs on my on-prem cluster, reduce my resource consumption by 30%. So that way, when I forecast this into the cloud, I can actually have 30% savings, theoretically, right? Or I'm in the cloud today and I'm trying to further reduce costs. We have that ability too. This is a self-service way to really just try to, get like the feel, the true value that we're able to provide in your environment with the data that you select today. We do have an FAQ there. So if you have any questions in terms of security and how we set this up, again, we make this so that way it's a self-service way for you to really try out Unravel without having, somebody like myself pushing you guys. Obviously, I'm always there and available to make sure that you guys are getting, the most value and asking your questions. But if you're more wanting to do a more self-service route, we have that option as well. And with that, thank you, folks.
And wait, before you get away, there are a couple of questions. So
okay.
If you don't mind, I'll put you back on camera so everyone can see your smiling face. Okay, just a couple of quick questions.
Sure.
How long does it take to install Unravel?
Yes, a great question. So a matter of like, we've got a very simplified, streamlined, automated process. It only takes, I'd say average about like an hour or two, depending on how complicated things get, but it's actually a really, really light install, guys. So if you guys want to do that, we have that. We also have the SaaS offering, but again, my only caveat with that is it's not just, that's more for them from a management standpoint, but yes, we can definitely work with you guys to make sure that we can get this installed. And so that way you guys can see value and hopefully continue to use Unravel in your cloud migration journey.
Perfect. And then there's two more. How long does the tool need to run before it starts generating some insights?
That's a great question. So as soon as you do the installation, day one, we start collecting data. You could potentially use the tool like in day 2, day 3, but usually what we'll say is let it run for like 7 days. So that way you have like a good week data set. Obviously, the longer, the better. But, that's, as soon as installation, we start collecting. But my general recommendation is wait about a week before we can start really giving you some really, really good insights about your environment.
Okay. And the last one, what do you do with Databricks?
Great question. Databricks is hot. No doubt about it. It's a great technology stack. For folks that don't know about Databricks, these guys are the ones that have been pushing Spark, to the mainstream. We do support Databricks. And so some of the things that I've shown were more specific about, just, on-prem workloads itself. But, we do have a strong partnership with Databricks, helping them, with some of their folks that are looking to migrate to Databricks. And so that is absolutely something that we can provide. And so if you are a Databricks customer, feel free to reach out to me and I can give you a little bit more details on how we can help in those scenarios.
Wonderful. Thanks, Chris. That is all the time we have for today. This webinar will be available instantly on demand, so please feel free to come back and view it or share with colleagues or peers via the same web address. If you are watching on demand and would like to ask a question, please feel free to email hello@unraveldata.com. Let us know what you think of the session by rating this webinar and if there's any other topics. With that, I'd like to thank Chris, as always, for sharing his expertise today and for your time today. And we hope to see you at a future webinar. Thanks so much for your time.
Great.
Thanks,
folks.
Chris.
Thank you. Thanks, Diana.